Okay, now we're in chapter 3. Chapter 3 is all about polynomials, and in this chapter, the first section, we're going to talk about quadratic functions. Students will be able to sketch a graph of a quadratic function and use a standard form of a quadratic function to sketch the graph of a parabola and find the equation of a parabola given its vertex and point on the graph. We're going to construct and use quadratic models to solve applicable problems. I'm probably not assigning any of those for this class, but everything else we're going to be doing. So what is actually a quadratic function? It says let a, b, and c be real numbers where a does not equal 0. Well, if you look where a is, if a was 0, the x squared part wouldn't exist, and that's pretty much what gives it its parabola shape is the squaring. So a just can't be 0. The function of x is given by f of x equals a squared plus bx plus c. It's called a quadratic function. It says example 1, sketching the graph of a quadratic function. Graph each quadratic function using the table of values. What is the domain and range? So whenever we don't know how to sketch any kind of function in mathematics, I always suggested using a table of values with some positives, some negatives, and 0. So you could have used 1, 2, 3 or 2, 4, 6. And as you get better with graphing, you know what numbers to use. So I filled in my table 1, 2, 3, and -1, -2, -3. So when I square 1, I get 1. When I square 2, I get 4. And when I square 3, I get 9. When I square 0, I get 0. When I square -1, I get 1. When I square -2, I get 4, and when I square or substitute in -3, I get 9. Notice that 3 is equidistant from 0, the center, or the vertex is actually what we should be calling it, the same with -3. Then your outputs are going to be the same if they're equidistant from the vertex. So we're going to graph this as 0, 0, and over time you'll just realize what your graph should look like. So it should be a mirror image here. It's going to have this U shape like we said. A parabola is the name of this U-shaped curve. They're going to be symmetric. Now, it's like we have this axis of symmetry, just like when you're little, learn about the axis on the earth. We have this axis of symmetry, which cuts it right in half. And our axis of symmetry, if you have a line straight up and down, that's an x equals equation, and it goes through 0. Okay, so we're going to call that our axis of symmetry. And it's more so you understand terminology. I'm not going to quiz you on necessarily the axis of symmetry, but if somebody's referring to it, I want you to know what that means. It cuts it right in half in this most important point called the vertex. Now, the vertex is your highest or lowest point on a quadratic. Here, it is the lowest point, but if for some reason we reflected, it would be our highest point. It would be a maximum, and right here it's a minimum. It asks what the domain and range is. So logically, if you think about it, what numbers can you square? We squared positive numbers, we squared negative numbers, and we squared 0. So our domain was all real numbers, and our range, okay, or you could say from -infinity to infinity, and our range, there's nothing negative, we got 0 or greater. So you could say y is greater than or equal to 0, or you could say we start at 0 and go to infinity. Now, if I were to graph this quadratic and compare it to this quadratic, what would the shift look like? It would still keep its same shape, but it would go down 3 units, and it would actually, we said, go to the left 2 because it's actually subtracting a negative. So the beauty of transformations is you don't really have to change much. So if you look in your textbook and they want you to look at this function and find the picture on the graph, you notice that your vertex was 0, 0, but if it's going to the left 2, 1, 2, and it's going down 3, 1, 2, 3, now your vertex is going to be here. So same thing, all the points are going to have shifted. So 1, 1, 2, 3, 1, 1, 2, 3. So it's going to shift like this. So in your mind's eye, without even drawing it, you should notice that would go down 3 and over, okay? So that is how you graph a quadratic. When in doubt, always make a table. The vertex is the lowest point or the highest point. It's a U-shaped curve called a parabola, and it always has an axis of symmetry that cuts it in half. Its domain is all real numbers, and its range depends on what quadratic you have. Here, it's always at 0, 0, but the vertex now is at 2, -3. So our range here would just be greater than -3, not 0. Well, this form is very different than, let's say, a quadratic that was in this form. This is a quadratic function, and this is what your textbook calls standard form. It depends on the textbook you have. The textbook I teach with at another school this is standard form, and this is vertex form. So if you call it vertex form, I'm not going to say that's incorrect. I might refer to it as vertex form so you can see the vertex and it makes a little more sense. But your textbook does call it standard form because HK is your vertex. So here, this is in vertex form. Your vertex was 0, 0. Your vertex here is actually -2, -3. A would be your vertical stretch or shrink, okay? There can be a number there that doesn't have to be. So this is said to be in standard form. The graph of f is a parabola whose axis is the vertical line x equals h. So no matter what your vertex is, this line of symmetry goes through it is what they're saying, and your vertex is hk. When a is greater than 0, the parabola opens up. When a is less than 0, your parabola opens down. So if it's negative, frown face. If it's positive, happy face. That makes sense, right? Okay. Example 2 and 3, these are a little tricky. These are not in vertex form or standard form your book calls it. It's just a quadratic function. Now, you can move them into vertex form. And if you think back to linear equations, this was slope-intercept form. This was standard form, okay? And what other form did we have? Oh, like point-slope form, let's just make one up. So these are all linear equations, but they're just in different forms. So with quadratics, you have the same thing. You have quadratic functions, but they're in different forms. In order to get a quadratic into vertex form or standard form, you need to have the same quantity twice. So what that means is, are you able to factor this quadratic so that you see the same quantity twice? Well, yeah, if you factor 9, you're going to get +3 and +3. And why would we want that? So that you can condense. And now it's in vertex, or what your book calls standard form, and you can see the vertex. So the vertex here is technically, the 1 is in front, you don't really write that, and there's a 0 here, but you don't write that. So your vertex here would be -3, 0, and you can use that to graph. To graph a quadratic, we use those tables of values, but what if your graph is shifted way over? You're not going to want to use 0, 0. You want to start with your vertex. So if I were to graph this function, you would start with your vertex. And you'd put -3, 0 in the middle. And then you pick some points greater than -3, and you'd pick some points less than -3. So you would pick -2, -1, and -4, -5. And that's how you would graph that function that way. So you always start with your vertex. Why do we start with 0, 0 on our notes? Well, it's the vertex. So here, we'd figure out the vertex, and we would start graphing with a -2, -3, and then we'd work our way from there. Now, there's a lot of information in this unit, but this book is thinking that you do know some of it because it's mostly an Algebra 2 textbook. So if you need more practice with these, I would just Google, this is called completing the square, what we're about to do, and it's a method to complete a square, to get the same thing twice in order to create vertex form. So they're assuming that you kind of know how to do this. So what is completing the square? Well, let's look at this next function. Some of these aren't in your examples in your textbook because I'm trying to make a gradual progression to the next example. Now, this worked out conveniently for us, but what happens when we have an 11? The only way to factor 11 is 11 and 1, and we don't get the same thing twice. So that 11 doesn't help us at all. So we're going to tell it to scooch over, and we're going to put a number in here that will help us. So how do you find that number 9 to get the same thing twice? Well, you see that that 6 is cut in half to be a 3, and then you square 3, you get 9. So in order to get this new constant, you take your b, you divide it by 2 or cut it in half, and then you square it. So if your b is 6, you divide by 2, and then you square it, which would be 9. But you can't just throw a 9 in. That will totally change your equation. If you add a 9, you got to subtract a 9. If you add 7, you have to subtract 7. If you add 20, you have to subtract 20 to keep it balanced. But everything has to stay on one side, so if you add 9, you better subtract it. And you might think, well, doesn't that defeat the purpose of doing this? No, it's where you put it. So if I put that new c here with my other stuff, I'm going to get x plus 3 times x plus 3. But now here I'm going to put these two numbers together because we can't just have that 11 go away. We just move it off to the side and have it deal with that negative 9 now. Well, 11 minus 9 is positive 2. So that is your original function. So if you were to graph this function and graph this function, they're the same thing. We just manipulated our numbers. So if you have a constant that doesn't work for you, scooch it over. You need to create a new constant. So you take this number, divide it by 2, square it. You have to add that number and also subtract it to keep that equation balanced. So here your vertex would be negative 3, positive 2. So that's what you would start with a table of values if you were to graph it. So you would start with negative 3, and you'd pick probably negative 2, negative 1, and negative 4, negative 5. And you would graph, and that's how you get a very accurate picture of your parabola. Now we're going to go one step harder. I have a negative in the front now. So not only does this 8 not work, but now we have a negative. So let's do what we did in the beginning. We need to complete this square. This 8 is not going to give us the same number twice. When you factor 8, you get 4 and 2. I don't want 4 and 2. I want the same number twice. So scooch 8 off to the side. So then we take our b, we divide it by 2, 3, and we square it 9, and we get plus 9 minus 9. But wait a minute, this negative is here. We only deal with it when a is positive. So remove the negative, and you're left with x squared minus 6x. This negative 8's off to the side. So really, our b is 6, negative 6. We divide it by 2, and then we square it. So what are we adding in? Well, we are adding in a 9 just because it got squared, it's now positive. So I'm putting a positive 9 in here. That means I have to subtract a 9 here. But wait, I'm actually putting in a negative 9, so I have to add a 9. You might have to rewind and redo some of these. You might have to grab a sheet of paper, try them on your own, and rewatch the video. You might have to Google types of examples of completing the square. You might have to go to other YouTube videos to relearn this process. Okay, your textbook immediately jumps to these types of problems, not these type. And if that becomes a problem, we need more practice, we can do that too. Okay, but for now, I'm just presenting to you what the lesson is for this book and what they expect from it. So they expect to know this for right now. Here, we need to factor this. I put that negative 8 and 9 together and I got 1. It's negative, so I need to have x minus 3, x minus 3. Let's see, x squared, yep. Negative 3x is negative 6x. Negative 3 times negative 3 is positive, yep. So now the whole point of us doing this is so that we get the same thing twice and we can condense it. So what is our vertex here? 3, 1. So when you make your table of values, you would use 3 and 1, and then you would do, you would use 3, 1, and then you would use a 4 and a 5 and a 2 and a 1. Okay. Now we're going to the next one. So same thing again. The 7 is not beneficial to us, so it scooches over. So we can find a constant that is. Now, this 2 is in the way, so I have to remove it. We have to have x have a 1 in front of it. So if I remove the 2, I'm also removing it from 8, and it becomes a 4. All right. 4 divided by 2, and then squared is actually going to be a 4. So if I add a 4 in there, I also have to subtract a 4 to keep it balanced. However, am I really adding 4? I'm really adding an 8. So I have to subtract an 8. Most of these examples that I'm completing are the ones that are in your textbook. So you can always read the textbook as well. And now we can factor the insides. And if they don't have the same thing twice, then we did something wrong, because that's the whole point of why we are doing this, so that we can put it in vertex form, or what your textbook calls standard form. So your vertex here is -2, -1. And if you have these problems in the book and it says, knowing this function, identify its graph, you just look for that vertex. Okay. Last one. Before I keep going, this video is a lot. Right now we're at 17 minutes. What I suggest is when you have a few examples, stop, try the homework. In your textbook, it'll have the problems that you're working on. It'll say beside it what examples it goes with. Like see example 1, see example 2. Try the ones that have that example with it, okay? So for this instance, it's example 4. So it's towards the end of your problems. Now it says, if you're given a graph, can you write an equation? So we're given a parabola whose vertex is 1, 2. Okay, so there's a point at 1, 2. I don't know which way it goes, but it passes through the point 0, 0. Well, if that's its vertex, it must go like this. Okay. You don't have to draw a picture, I'm just showing you. They want you to create an equation in vertex form, or what your book calls standard form. So if this is the formula, they're telling you, hey, you have a vertex at 1, 2, and it goes to the point 0, 0. Well, 0, 0 is an x value and a y value. So that means what's your A? Is there a vertical stretch? Is there a vertical shrink? Maybe there's not. Maybe A is 1. Oh, A is -2. So our equation is y equals -2x minus, what was h? 1, and k is 2. So you need to have the vertex in there and whatever A is. So you plug everything in to find A. Once you found A, put A in, put your vertex in. So pause the video and you try the exact same way with this point and this vertex. Okay, so vertex HK is 3, 4. Your x value is 2. Your y value is 5. 5 equals -1 squared plus 4. 5 equals A times, well, -1 squared is 1 plus 4. Subtract 4 from both sides. A is just 1. And that's a lot of the times the case, and that's fine. Therefore, your equation is y equals, you don't have to write the 1, x minus 3 squared plus 4. And that's it. Okay, try to get this done as much as you can before I see you guys on class. And I'll answer questions. This is due Tuesday at midnight.